Hello, welcome back to your integral calculus. Okay, so we will now proceed with your module 3. So this is now your definite integral. Okay, so your previous module we discussed about the indefinite integral. Okay, so it is also discussed there. Why is it that we are having there your why is it that we call this one indefinite? Okay, that is actually because of your constant c. Okay, and there are a lot of cases wherein your constant c will have more than one value. Okay, so that is discussed in your indefinite integral. So how about this definite integral? Okay, so this is our topic for module 3, and we will be discussing here your unit 1 general property. What is the general property? So just like indefinite, we have also general property for definite. Okay, so by the way, your properties in your indefinite, we are still carrying it in your definite integrals. There will just be additional, okay, additional property. And then we will be discussing also in your unit 2, which is also in this video, your integrals of odd and even function. Okay, so what are these? So in this unit, these are your desired learning outcomes. First is to define what is definite integral, and then second is to identify the general properties of definite integrals, and of course to define odd and even function with respect to definite integrals. Okay, so first, definite integral. Okay, so if we will try to recall that the derivative and the integral are two fundamental concepts that conforms the core of calculus. So again, if you recall your what we call this one, differential calculus, and then of course relate that with your integral, these are just the reversible process. Okay, so the derivative was introduced by the way of notion of instantaneous rate of change, or actually most of the time that is slope. Okay, related to slope, if which the velocity of one of the most familiar concepts. Okay, so velocities, what are the other applications of your differential calculus? Maxima minima, if you are using it as a slope, you can make use of it in maxima minima. Okay, if you are taking it as a rate of change, or we can relate it to velocity. Okay, so there are a lot of application of your derivative also. And then this indefinite integral. Okay, so this is antiderivative. Of course, this is integral. However, there are just two types of integral, the indefinite and indefinite. And again, as I'm saying, indefinite is already discussed before. Okay, so in indefinite integrals, we are trying to reverse the process wherein you have your equation and you differentiated that one, you will have your differential equation. And then what we have now is a differential equation, reverse it back to the original equation that is indefinite integral. Okay, so we are dealing with equations. Okay, that equation might be representing something. Okay, so that is indefinite integral. So we will now go to your definite integral. Okay, and the evaluation of this is of course using the knowledge of your indefinite integral. Still, you are using the properties of your indefinite integration. Okay, so one striking difference between the indefinite integral and the definite integral is that the later, or the definite integral, is a real number, while in your indefinite integral you will end up with equation. Okay, unless you will have a value of x, then that is what you will substitute, so that you will have an answer of a real number. But if you do not have that, then you will end up with an answer of your indefinite integral for equations. Okay, to be equations. Now in your definite integral, we will directly end up with an answer of real number. Okay, so it is for the fact that we can link the definite integral to the concept of area. So one example or one application of this definite integral is actually area. Okay, so we will discuss that one along the way. We can also make use of this to evaluate volumes and so on, and centroids. Okay, so that is definite integral. So let's now start. Okay, so this is your property, or this is your what we call this one. This is the form of definite integral. Before, we do not have this a and b. That is just integral of fx dx. You will end up with fx plus c. isn't it? That is indefinite integral. Now we do not have that plus c. I will explain that one later on. So now what we have is a and b. We call this one the limits. A is the lower limit and b is the upper limit. Okay. How we will read this one is the definite integral of function y, or you can, if that f of x is y, or function f of x from a to b. Okay, so that is the definite integral of function y or f of x from a to b. So again, x is our variable there, and of course dx is your differential. So f of x is your integrand. Okay, that is our integrand. So in our answer here, there is no such as plus c. That will be equal to a real number. Okay, so that is definite integral. So how are we going to do that? Is to the same actually as I'm saying. We will end up with equation. Okay, we will end up with equation, and then of course we are not yet done with the integration because we are going to deal with these limits. Okay, so that is just like in your definite integral is you will apply the indefinite integral, but you are not yet done. You need to apply the limit. So that is definite integral. Okay, so again, this is the form integral of f of x dx from a to b. That is how we will read this one, from a to b, or from x equals a to x equals b. Okay, since our variable is x, and actually the meaning of that is you are trying to get the value of this function. Okay, you are trying to get the value of this function when x equals a to x equals b. So we are trying to accumulate the value of the function, isn't it? You can say y is equal to f of x. At certain values of x, there is a value of y. Okay, isn't it? If you will try to change the value of x, you will have another value of y. So if you will say definite integral, we are just trying to summate. Okay, that is summation. Summate the value of the function from x equals a to x equals b. So that is your definite integral. So what is this summation? That is now a real number. So if you will now integrate, of course, apply your indefinite integral properties, you will end up with a function, but there is no plus c already. Okay, I will explain that one later on. There is no such as plus c. Because that will actually cancel out, because if that is your answer and we are still to apply your limit, upper limit and lower limit, so that is the meaning of this subscript and superscript here, our a and b. If you already apply the indefinite integration, or if you already reverse the differential equation into an equation, then all you need to do is apply the limit. So I did not yet apply that, so I will write it this way. Okay, a to b. Then the meaning of this is substitute the function, or I mean get the function of the f of x from a to b. That's why you will have here f of b minus f of a. Okay, so let me explain this one on a figure so that you will better understand. Okay, let's say, okay, you have there your f of x dx. You are going to integrate that one from a to b. You are going to integrate that one, you will end up with f of x. Okay, that big f stands for the equation. This is the derivative or your integral. Okay, this is the differential equation, that is the equation. Again, in your indefinite, that is plus c, but we do not need to write that one. Okay, I will explain that one later. And again, if your f of x is actually a function, let's say that is equal to y, then you can just say, okay, sige, let's try to consider that one in a graph. This is x, this is y. Okay? You are given the differential equation, and you are trying to get the value of the original equation from x equals a to x equals b. That is the meaning of this. So for example only, okay, for example, that is the y equals f of x. Let's say that is y is the f is equal to f of x. So let's say this is x equals a, and that is x equals b. Okay, x equals a, x equals b. So you are trying to, okay, from your differential equation, you are trying to get the original equation and then get the value from x equals a to x equals b. This is x equals a to x equals b. So we are trying to get this value between x equals a and x equals b. So whatever that value, whatever that function symbolizes, or whatever that function, what do you call this one? Whatever the value of that function. Okay, so again, what do you call this one? We will try to discuss this one in your area, but let me discuss how that plus c is actually cancelled. Okay, so let's try to explain the meaning of that f of x from a to b. Okay, so it says there that that is f of b minus f of a. Okay, f of a minus f of b. It means that we are going to substitute, get the value from x equals at x equals b. Okay, get that value. It means that the value from x equals b is referred to from the origin or from the beginning or the start of that function. And then you will get the value of the function from the beginning to x equals a. So what do we have is this is your, okay, you can say that is your f of b, and then you can say this is your f of a. So what we are trying to get is this one. Okay, this is what we are trying to get. This value from a to b. So what will I do is, for me to get that this is your f of b minus f of a. So how will I get that one is, of course, just subtract. Getting the value between a to b, subtract the value of f of b, subtract the value of f of a from that f of b. Okay, so that is the value of our, or that is the meaning of this one. So how did that plus c is, how did that plus c being cancelled? So if you are trying to get this one, okay, so f of x plus c. Okay, let's say that is the answer for applying the indefinite integral properties. So what you're going now to do is substitute your upper limit and lower limit, isn't it? Substitute the value of x to be a and to be b. So if I will do that, you will have here f of x b. You do not need actually to worry about c, since that will be actually cancelling. So what will I do is substitute x as it is equal to b. So whatever that function is, that could be simple or complicated, you are going to substitute the value of x. So still there is that plus c, since that is a constant, isn't it? However, all of the value, all of this value of f of b plus c will be subtracted. Okay, will be actually reduced by substituting your x equals a. But still there is plus c. Okay, now I will simplify. I can erase the grouping sign. This will go minus and minus. So f of b plus c, and that will be minus f of a, and then that will be minus c. So actually plus c and minus c cancels. You are just left with f of b and f of a. So again, that is why we do not need to be worrying about this constant of integration in definite integrals. Okay. So again, definite integral is getting the value, okay, from a certain value of x, from a certain value of x, whatever that function is representing, whatever that function is representing. Okay, so that is definite integral. So these are the additional properties, okay, additional to your indefinite. Okay, so if you have your integral from a to b of f of x dx, that is equal to negative integral from b to a of f of x dx. Okay, so what is the meaning of that? If you are trying to reverse, the limit, isn't it? Let's consider that b is a bigger number than a. So you will expect that the value, if you substitute x equals b, is bigger than x equals a. But if you will try to reverse the process, isn't it? You are trying to subtract f of b minus f of a. So if you will try to reverse the process, now you are subtracting a bigger number from a smaller number. Okay, so that is your first property of definite integral. So here is the second property. Okay, if a equals b, if your upper limit and lower limit are equal, actually you are dealing with the identical values of x. So if you will substitute the upper limit, you will end up with a value which is the same in substituting your lower limit. So subtracting two different values to the same values will end up actually zero. So again, so if you're getting a value, it is just like, okay, get the value from A to A. So what is the value between? Actually, there is none, since you are just referring to a single value. Okay, so that is your second property. Third is that if f or the function is continuous on A on B, and that C is between them. Okay, let's say you have there a third value of x. Okay, let's say you have a third value of x. Let's say you have A and B, and you have and that is continuous from A to B. It means the function is continuous, isn't it? In your in your differential calculus, you talked about continuity. So if your function is continuous from A to B, and you have a third value in between them, okay, in between A and B, you have, let's say, C, then actually you can cut the differentiation into two. Okay, so I will explain this one in our figure again. So you want to get from A to B, and let's say you have a number in between. Let's say that is x equals C. Okay, that's x equals C. Then still you are after from A to B. You can actually break this down into two. You can get the integral from x a to xc, the number in between, and add that one to the integral from c to b. So again, you can break this down if your third value is in between your a and b, and a and b is continuous. Okay, if we say continuous, that is continuous, the function is continuous. Because again, for example, if from a, that is your function, and going to b is that way, it means they are not continuous. So you cannot actually say that subtracting a from b, that is the entire value. Okay, so that is a different topic. That is not possible. Okay, so it will only be applicable if your function is continuous from a to b. So if that is the case, then you can actually consider a number in between them, and that could be your divisor, or what to call this one. That is our breakage, so that you can just divide this one into two. You can get the integral from a to c, and then get the integral from c to b, and then add this one back. That will still be from a to b. Okay, so that is the meaning of your third property here. You can actually, if c is again a value in between a and b, then you can actually get your integral from a to c, and then from c to b, summate this one, add these values, and then you will end up still from a to b. Or you can actually consider more than one. Let's say there are more points. Let's say there is another or fourth value d. So you can say a to c, c to d, d to b. Then you will summate all of this. You will end up with your still a to b. Okay, so that is another property of definite integral. And here is your number 4, if k is a constant. Okay, if k is a constant, that is just like your what do you call this one? This is actually a property. This is actually a property of your indefinite integral. So bring that outside, deal with the integration of the function. Okay, and same thing here. If you are adding, okay, if you are trying to add, if you are, not trying to add. If you have two different functions, f of x, that should be j of x. Okay, that should be j of x. Okay, so let's just change that one. F of x, so that it will now actually dictate that they are two different functions. Okay, or you can just say that is u and v. Okay, so again, if you are integrating a sum or difference of two different function, or more than different function, So again, f of x and g of x are two different functions. Then actually you can distribute that definite integral. Okay. So getting your real value of the integral from a to b of f of x and adding that one to your integral of g of x from a to b, submitting this one is still the same. Okay. Individually is still the same if you will actually simplify this one and then integrate this one. So that is the fifth property of your definite integral. Okay, so these are the property additional to your property before. Okay, your what we call this one, what are our properties before is product, quotient, and of course your techniques and so on and so forth. So this is now actually your unit 2, add an even function. Add an even function. So add an even function. Okay, so what is add an even function? Okay, so if f of x is defined in the interval negative a to a and f of negative x is equal to negative f of x, then f of x is called an add function. It can be shown that for an add function, the f of x, okay, the integral of that function f of x, add function f of x is equal to 0. And okay, if f of x is defined in interval negative a to a and f of negative x equals f of x. Okay, in this one, in add, if you will make your x negative, and that will be the negative of the original function, that is add. But in even, okay, even if you will try to make your x a negative x, still it will be the same as the original, then that is what we call as the even function. Okay, then it can be shown that for that even function f of x, the integral is actually twice. Okay, you can cut this one since isn't it a negative a to a, you can actually consider a number between, let's say the number between is 0, so you can actually get the limit from 0 to a and then multiply it to 2, that is the same as negative a to a. Okay, so that is your add in even function. So let me give you an example of add in even function. Okay, that you will not be confused. So let's say let's start with add. Okay, example of add is this. Okay, if your f of x, let's say this is our f of x, is let's say 4x cubed minus 2x. Okay, let's say this is actually an example of add. So how do you know that that is add? Okay, how do we know that this is add? If I will try to change this x into a negative x, so this will become 4 negative x. Okay, your x will become a negative, and that is cubed, minus 2 times your x, which is negative. Okay, it will become, okay, 4 negative and negative, actually negative, you are just actually raising negative 1 to 3, it's still a negative, so that will be negative 4x cubed, and negative will make it as plus 2x. So actually, if you try to look at this, isn't it that this original equation is just like multiplying with a negative, you will end up with this. So if this is f of x, this is actually a negative f of x. Okay, why? Because actually you will try to factor out a negative there, negative 4. Try to factor out a negative there. If you try to factor out a negative, you will end up here with positive 4x cubed, negative 2x, which is actually your f of x. And actually that is a negative. So that is example of add. Okay, we will try to integrate this one. Why is it that that will become 0? But later on, okay, we will try to integrate this one. And this is an even function. Okay, this is an even function. For example, is to say f of x is equal to 5x4 minus 3x squared. Okay, so let's try again to check if this is odd or even by making your x a negative. So 5, this is negative x raised to 4 and minus 3, negative x squared. So if I will try to do that, okay, if I will try to do that, negative raised to 4 is still positive. So that is still 5x4, which is positive. and negative x squared is still positive. So that is still 3x raised to 2. So isn't it? This is f of x and that is still f of x. Even if we will make your negative, even if we will make your negative, your x a negative x, that is still the same. So again, if nothing happens by changing a negative x, by changing the x into a negative x, that is what we call the even function. If you will try to make a negative, okay, if you will try to make a negative, the negative x, the x into a negative, and you will end up with a negative of that function. This is the add. Okay, so that is add and even function, and these are the integral of add and even function. But actually, this is just to explain only why we will have this 0 and that is equal to 2 integral from 0 to a f of x dx. Okay, so we will go back here later once we will have an example. Okay, so that is add and even function. Okay, so let's try now to apply your what is this one? Indefinite integral properties. Okay, so example 1, so integral of x squared dx from 2 to 4. That is how we will read it. Okay, so again, forget first about your limit, just deal with this just like indefinite. So this is power rule, isn't it? X is your u, dx is its du, so that is just power rule, u n plus 1 all over n plus 1. So again, x 3 all over 3. Now all we need to do is apply your limit from 2 to 4. So substitute your upper limit first. Upper limit minus lower limit. So 4, substitute there, it will be 64 over 3. Lower limit, substitute there, it will be 8 over 3. And then, now subtract f of 4 minus f of 2 or f of b minus f of a. So 64 over 3 minus 8 over 3, that is 56 over 3. So that is our integral of x squared dx from 2 to 4. Okay? So we are just following this formula of our definite integral. Number 2. Okay, so integrate this one. This is actually again, you can distribute it. You can distribute if you want. Okay, that is a property of definite integral, isn't it? You can distribute. Or if you want, you can actually integrate directly. There is no problem about that. So in this solution, we distributed. Okay, so you can actually integrate this one right away and then apply the upper limit, lower limit. But okay, let's follow the property, but you can do it right away. Okay, so 3x squared dx and then integral of 2 dx. Okay, so integrating that one, power rule, this is just x, so you will end up here with 3x squared will to be x cubed all over 3, so 3 and 3 cancels, and then of course this will be 2x. Okay, 2x, because again that is just 2 dx. Okay, so now apply your upper limit, lower limit. Upper limit is 5, so that will be 135. Lower limit is 1, so that is 3. So subtract upper limit minus lower limit, we will be having 132. So that is your integral. Okay, one more. So integral of this times that. So this is a product, but of course, we cannot take it. There is no such as product rule, isn't it, in your indefinite? So what we are going to do is actually you can expand and then multiply, or isn't it, you can think of this as your u and that 4 is n and that could be your du. So if I will try to put this x squared with your dx as my du, the only missing there, so that will be the derivative of your x cubed minus 1. What is the derivative of x cubed minus 1 is 3x squared dx, isn't it? And what do we have only is x squared dx, so I need to write there 3 and I need to balance that by 1. Okay, so apply now. Okay, this is now power rule. U n plus 1 all over n plus 1 and multiply to that balancing factor. Of course, apply your upper limit, lower limit. Okay, so this is now the simplified of that. Apply your upper limit. That will end up with this fraction. Lower limit, that will be a negative 1 over 15. Okay, that will be negative 1 over 15. And then you will now, okay, substitute there. Upper limit minus lower limit, you will end up with this, or in the decimal value. Okay, so that is definite integral. But before we will go to the review of concepts, okay, let's try to answer this given formula if that is an even or an odd integer or an odd function. So let's try to integrate this one. Okay, integral of this, since we know that that is odd, okay, integral, for example, we do not have there a value of a, negative a to positive a, so let's say negative 1 to positive 1. Integral of 4x, our f of x cubed minus 2x dx. Okay, so let's try to integrate this one. Okay, let me just write it here. From negative 1 to 1 of your 4x cubed minus 2x dx. Okay, so integrating this one, okay, again, that is this power rule. So n plus 1 over n plus 1, so x 4 over 4, and 4 cancels, so that is just x4. And then this is 2x raised to 2 all over 2, so 2 and 2 cancels, you will have minus x squared from negative 1 to 1. So applying your upper limit, okay, so apply your upper limit. Substitute your upper limit, substitute your lower limit. So substitute 1, that is 1, that is 1, so 0. Substitute this one, okay, x raised to 4 is negative 1, negative 1, I mean still positive 1, and that is still positive 1, so it will still be 0. So even if you have here a value, or let's say values and values, they are the same, so they will still be 0. Okay. Okay, maybe you will be confused with this. Why not? Let's make it as a. What if we will make it as 2? Let's say 2. Let me just change that one to negative 2 to positive 2. Negative 2, positive 2. So this will be x raised to 4. Okay, let's try to calculate it one. x4. 2 times 2 times 2 times 2 is 16 minus 2 times 2, which is 4, so that is 12. So let's try that one. Let's change so that you will not be confused with 0. Okay, so that will be 16. 2 raised to 4 is 16, and that is 4, so that will be 12. And then lower limit is still positive 16. Still positive 16. So even that is negative, since that is what we call this one as odd. I mean even number. So that will be 16, and this is still positive 4. So subtracting upper limit minus, this is still 12, so that is still 0. So even if you try to cut this one, okay, let's say you want to get that one, break this down into integral from negative 2 to 0, and then integral from 0 to positive 2. Okay, use the third property. You will still end up here with 0. Okay, so that is if it is odd. Okay, if that is odd function. How about if it is even? Okay, so okay, let's use the same. Or let's say 1. Or say the same. Or 1. Okay. Negative 1 of 5x4 minus 3x squared dx. So integrating this one. Integrating this one, will be having this as integrate n plus 1 over n plus 1. So 5x raised to 5 all over 5. So 5 cancels, you will have x raised to 5. And then minus 3x, n plus 1 is 3 all over 3. So 3 cancels, you will have it x cubed. From negative 1 to 1. Okay? Substitute your upper limit. So 1. Okay. Ito naman. So why not change it to 2? Para we have a value. Negative 2 to positive 2. Okay, actually that is applicable, negative 1 to 1, but actually you will be confused with 0, 0. So what if, let's say, negative 2 to 2, negative 2 to positive 2, substitute your upper. So 2 raised to 5, 16 times 2 is 32, minus 8, isn't it? X raised to cube is 8, 32 minus 8 is 24. And then minus your lower limit, which is x raised to negative 5 is negative x is negative 2, so that will be negative 32 minus, this will be, okay, this will be negative 8. So negative 32 minus negative 8 will actually be negative 24. And negative and that minus will actually make it as plus, so you will end up here with times 2. So this will be 48. So as you can see, they are actually the same value, okay, but different signs. So they will end up added together because of that minus. So you can actually consider it is still as from negative 2 to 0. You will try to use your property tree. You can break down. You can consider a number between. Let's say, let's get the middle of that 0. You can get the 0 to 2. And then try to submit that one. You will end up with, okay, 24 plus 24, which is to be still 48. Okay, so if you try to cut this one in the middle, you will from negative 2 to 0, and then from 0 to 2, this will be giving you 24, that will be giving you 24, so that will be giving us 48. That's why in this one, in even, they simplified it as twice, okay? They simplified is this one as twice the integral from 0 to a of whatever f of x dx. Since again, what you will be getting from half of that is the same as the other half on the negative side. So all you need to do is from 0 to that, then multiply it to 2, you will still end up, even if you will start with the negative to the positive value. Okay, so that will happen in your even. In add, okay, if you will try to divide this one in between, this is equally the same value. So if you are subtracting that, this is equal the same value but opposite sign. So if you will add that one, they will end up 0. While in this, if you will separate it in between, they will be exactly the same and the same sign, so they will just be added. Okay, so that is add and even function. Okay, so that is add and even function. So these are the important concepts. Okay, so the principle of indefinite integrals are carried into definite integrals. So we are still using that one. And definite integrals are real numbers. Okay, so this is a real number. Okay, and definite integrals will be used for the application of integration. Okay, so that is what we will be using on the applications. Actually, there are applications of this indefinite integral also, but of course we did not discuss that one since we do not have much time. Okay, but that will just be dealing with okay, you will be continuing that in your, what do you call this one, differential calculus, differential equations. So that is your unit 2 and 1, okay, introduction. And now your unit 3 and 4, okay, so these are just additional about definite integral, additional techniques actually. Okay, so definite integral, change of limits and Wallis formula, unit 3 and unit 4. Okay, so change of limit. So in this unit 3 and 4, these are your desired learning outcome for you to define what is Wallis formula and to apply Wallis formula to integrands by changing the variable and differential and limits. So this is your Wallis formula. Okay. So this is a formula which is actually defined by Wallis, of course. That's why we call this one Wallis formula. And then that is derived in that if you have this form of integration, okay, you can just follow exactly this formula, then you will end up with the same answer even if you will try to apply step-by-step procedure of our integration, just like what we did here. Okay, but of course, since that is actually a powers of sine and cosine is in it, you will be applying our technique, which is transformation. Okay, transformation, powers of sine and cosine. So if you will end up with the sine of x raised to a number and cosine of x raised to a number dx from 0 to pi over 2. Okay, so we are referring here now to our variable is angle. So you have a limit of that angle from 0 to pi over 2 if you are in radians. But if you want that to be in degrees, then that is actually equivalent to 0 to 90 degrees. Okay, pi over 2 is 90 degrees. Since pi is 180 degrees, isn't it? Okay, so that is your Wallis formula. So if that is in this form, from 0 to pi over 2 sine mx cos nx and dx, that is just a Wallis formula. All I need to do is figure out the exponent of sine, exponent of cosine, then I will just be playing around with that. You will end up with the answer. Okay, so let me just explain this one. So what we are going to do is m minus 1, okay, the exponent of sine, start by reducing it by 1, multiply that 1, if you reduce it by 3, multiply that 1, reduce it by 5, and so on and so forth. So as you can see, you are reducing 1, 3, 5, and so on and so forth, going to this, you are just following, subtracting the add numbers, up to the time you will end up with 2 or 1. So, okay, let's say you are given here a number. First is subtract 1. That will be your first multiplier. Subtract 3, second multiplier. And so on and so forth. 5, 7, 9. Up to the time you will end up with 2 or 1. Okay, so which one goes first? That is the end. So if you ended up with 2, stop already. If you ended up with 1, stop already. Okay, 2 or 1, stop. Then that is for our m. Then for our n, the same thing will happen. Subtract 1, subtract 3, 5, 7, so on and so forth. Up to the time you will end up with 2 or 1. Okay, so these are our multipliers for m, multiplier for n, and then this is still, we are going to multiply all of them. Okay, then our divisor for that is, okay, all you need to do is add your mn. So that is our first multiplier here, m plus n, and then whatever that sum here, subtract 2, subtract 4, subtract 6, and so on and so forth up to 2 or 1. So as you can see on top, we are taking m and n one by one, subtracting odd numbers up to the time we will reach 2 and 1. For the denominator, we will add. Okay, we will add the m and n and then start subtracting. Okay, so actually in here we started subtracting 0 since that is the first even number, isn't it? On the positive side, positive even number. 0 is still considered. So m plus n minus 0. Actually, you do not need to write that. And then minus 2 and so on and so forth. Up to the time you will end up with 2 or 1. But this is what you should not forget. In Wallis formula, there is a multiplier alpha. And that alpha has a value. Okay? M and n again is a non-negative. That should be non-negative integers for you to make use of your Wallis formula, because of course if one of these or both of these are negative, you cannot reach your 2 or 1, positive 2 or positive 1. So you cannot use Wallis if that is negative 1 or one of these is negative. Okay, so this is only in the form sine times cosine. Okay, and you should have a limit from 0 to pi over 2. Okay, what is that alpha? That is just a multiplier. It's either 1 or pi over 2. Okay, so what is that? That will be pi over 2 if both of them are even. Okay, if both m and n are even, then of course even positive, since we are talking here of non-negative integers, or this should be just positive integers. If m and n are positive even, then you will use here pi over 2. But if one of them or both of them is odd, okay, then that is equal to 1. Okay, so that is our alpha. If either m or n is even. The meaning is that of that is actually if of one of them or both of them is odd, then that is 1. Okay, simple as that. So again, for us to save time integrating your powers of sine and cosine, if you have your limit from 0 to x over 2, then you can just apply Wallis formula. Okay, so example for applying Wallis formula here is, as you can see, from 0 to pi over 2 of sine 4x cos 2x dx. Okay, so our powers are positive. So actually you can apply power or what we call Wallis formula. So let's start with your m. If m is 4, m minus 1 is 3, m minus 3 is 1. So we already reached 1, so it's stop. Okay, and then start with n, which is 2, subtract 1, that is 1. We already reached 1, so stop. By the way, here, do not say that it's 2 already, so stop. No. Even if you try to stop there, that will be the same. But it says there that we will not be using n right away. We need to, our first multiplier for n is n minus 1. So we need to get that n minus 1, which is 1. Okay. So that is our multiplier, m minus 1. m minus 3. So actually all you need to is subtract 1, subtract 3, subtract 1. So 3 times 1 times 1, that is our denominator. Okay? 3 times 1 times 1, which is actually 3. And below, add first your m plus n. So 4 plus 2 is 6. So that is our first multiplier there. And then 6 minus 2 is 4. 6 minus 4 is 2. So eventually you reach your 2, so you stop. Okay? So now that is our multiplier, 6 times 4 times 2. So that is our divisor. Now, okay, by the way, what is our alpha? Since both of them is even, so we will be using pi over 2. Okay, so all we need to do now is multiply 3 times 1 times 1. And then below is 6 times 4 times 2. And then your multiplier alpha, pi over 2, you will end up here with pi over 32. Okay? Even if you will try, to apply the powers of sine and cosine, and then applying your limits, okay, that will still be the same. So that is our Wallis. Formula. Okay, so this is another Wallis formula. Okay, so and could still be Wallis formula even if there is cosine, because you can actually consider cosine x raised to your n is 0. That's why there is no cosine here. So n there is 0. So actually you do not need to be writing there n equals 0 as multiplier, because that will be of course useless. So your m is 5, subtract 1, 4, subtract 3 is 2. Okay, so stop, you reach 2 already. So that's our multiplier. 5 times 4 times 2. But you do not enter there 0, because again there is no multiplier here to be n. And if you think that you will subtract here 1, which is 0 minus 1 is negative, so we cannot include negative in our multipliers. Okay, so now m plus n, so it still is 5. So minus 2 is 3, minus 4 is 1. So this is your denominator. So are both of them even? 0 is even, but 5 is odd, so no. So we will not be using pi over 2, rather that is 1. So 4 times 2, but of course 1, or actually you do not need to multiply from n. And then 5 times 3 times 1, and then your multiplier is 1, therefore that is 8 over 3. Okay, that is Wallis formula. Even if you will try, okay, you can check this one if you want. Okay, since we discussed your, what we call this one, properties, your transformation for powers of sine and cosine, isn't it? All you need to do is follow that one, and then try to evaluate your indefinite integral and substitute your upper limit, and then subtract your lower limit. That will give us 8 over 15 still. Okay, so that is your Wallis formula. What if, what if the point here is that, what if you do not have this sine mx and then cos nx, and you do not have that limit 0 over pi over 2, but you consider sine and cosine? You can actually do what we call as the change of limits. Okay, by change of variable, differential, and limits, an integral can be reduced to the form of which Wallis formula can be applied. So even if that is not on the form of Wallis, if you can put it in the form of Wallis by changing variable, and of course if you change variable you need to change limit, then you can use your Wallis formula. Okay. But this is of course not applicable in all of the problems. Okay, only some. And of course that will only be dealing with sines and cosines still. So for example here is that you have here cosine 8 3x dx and 0 to pi over 6. As you can see, in the first place your limit is not followed. That should be 0 to pi over 2. And then that is not just x. Okay, so what will I do? I will try to change limit here. Okay, I will try to change limit. Change variable first. Okay, so what if I want, instead of that to be x, let's say since that is x, I will use another variable, let's say theta. Let's say theta is equal to 3x. Okay, forget first about this. Let's say, let me just change 3x into theta. So if 3x is theta, then I need to change. Since I am changing the variable, I need to change the limit using, of course, my assumption. Okay, so 3x is theta. So all I need to do is substitute your original limit into your assumption so that you will get your new limit. Okay. So if x is 0, that's our lower limit. Substitute there. Theta is still 0. So that is our new lower limit. Now your upper limit, old upper limit or original is pi over 6. Substitute that. Pi over 6. You will end up here. 3 times pi over 6 will end up pi over 2. Okay. So this is your new lower limit, new upper limit. So substitute that now. Okay, but of course, we need to consider your dx since I do not have yet something to change the dx. Therefore, this is now where I will be using this. Rearrange, of course, bring out x and differentiate. You will have here d theta to be, okay, 3 dx, or you can rearrange that into dx is d theta over 3. Or differentiating this one, this is dx equals d theta over 3. So we have something to substitute in your 3x so that will be simplified. So that will just become theta. So that here. Okay, that will just become theta. And then of course we have something to substitute your dx, which is d theta over 3. And then later on, since we need to follow that x dx, or that will just be theta d theta. So I do not need 1/3. I will factor that one outside. And then of course your upper limit, your new lower limit now is 0, and then new upper limit is pi over 2. So we are now on the form of, okay, this one I factored out 1/3. So we are now on the form of Walli's formula, even if of course your variable is different. Okay, x will just of course be a general representation, but that could be any variable, as long as it is just the variable itself and the differential. Okay, Walli's formula. Okay, your your exponent for sine is 0. So we do not need to be writing that one. And then your n is, where's that? 8. Okay, that is 8. So minus 1, 7, minus 3, 5, minus 5, 3, and then minus 7, you will reach your 1. So stop. Add, so it's still m plus n. Since m is 0, it is still 8, minus 2, 6, minus 4, 8, minus 6, 2. Stop. Okay, now since actually m or 0 is even and n, which is 8, is even, so we will use pi over 2. Now apply your, what to call this one, substitute to the formula. These are our multiplier. Do not include that one since we are on top, isn't it? So 7 times 5 times 3 times 1. And then of course 1, or there is no need for you to write that one. And below that is 8 times 6 times 4 times 2. And then our alpha, which is pi over 2. And do not forget, there is that 1/3 outside. Okay, do not forget that one. Then, of course, multiply that one, you will end up with the integral to be 35 pi over 768. So that is integrating, okay, a powers of sine and cosine, which could be converted into Walli's formula. Okay, so this is just a technique in this case. This is a special case, okay. So please do not be using Walli's formula every time you will see there sine and cosine, because actually there are some cases. So how do you know if that is applicable or not is if you can see it exactly as in the form of Walli's, then that is Walli's. If not, then what you are going to do is try to change the limit. But even if you will try to change the limit, you will not end up with the form of Walli's, then you cannot continue. You need to go to our original way, or our conventional way of integration, applying the powers of sine and cosine, and then substitute upper limit minus lower limit. Okay, so you can actually check that one, powers of sine and cosine. You will end up here. Okay, so that is Walli's formula and change of limit. Okay, so this is just the important concept. The Walli's formula allows the easy evaluation of trigonometric function for the powers of sine and cosine. Okay, and then before the Walli's formula can be used, all the components must be defined properly. So again, you cannot just be using their Walli's without following or without putting that in the form of Walli's formula. And other types of function can be solved using Walli's formula with a few modifications of variable, differential, and limit. Okay, so that is Walli's formula. So, okay, if you have any question, comment below, or we will be discussing that next meeting. Okay, so thank you very much for watching.